Hello everyone, hope you all are doing well. So now we will start our next topic, that is radioactivity. The word radioactivity means the phenomena or the process occurring in an atom is called the radioactivity. In the radioactivity we are studying about the nucleus and the atom. In that one we are having three parts. Number one is nuclear phenomena. Number second, chemical reaction or change. Number third, physical reaction or change. So first of all we will talking about the nuclear phenomena. In nuclear phenomena, it's also called the nuclear reaction or change in a nucleus of an atom. Okay, so nuclear phenomena is a change in number of neutron and proton. Like if we are having a neutron and proton in a nucleus, so we are studying about the nucleus in a nuclear phenomena, the changing of their numbers of neutron and proton. After talking about chemical reaction or change, in this we are change in respect of electron. Like we have done that we are doing a reaction chemically, so participation of outer electron, always the outer electron participate in a chemical reaction, so it's changed its respect to the electron. Okay, after that move to the last point, that is physical reaction or change. Depends upon the binding of elements, means where the two elements bind together. Like in that one we are having two forces, electrostatic force and nuclear force. Talking about these two forces, we will talk further and about these two forces in next video. But it depends upon the binding, how which kind of binding. Like we are having two types of binding, weak binding and strong binding. Like we are having H2O, okay, in the form of water and in the form of ice. Now let me ask a question, that which one will be the strong one? So obviously ice have a more stronger binding, means physical reaction, and the water have a weaker binding with physical reaction. Okay, so after that move to next, a word radioactive. The word radio means a ray or a radiation. Okay, and active means the energetic or highly photonized. So we can say that energetic ray or highly photonized radiation. Okay, we study in nuclear phenomena, like change in the number of neutron and proton. So we study the radioactive in a nuclear phenomena. We can't see this with the naked eye because of the high speed of it, means as a high speed of light, so it's a high speed and having a high form of energy. Okay, when we break atoms, it release radioactive rays. Like we are having two atoms, okay, or one atom, we just break down it in the number of neutron and the protons, as I told you, in a nuclear phenomena. So it release radioactive rays that is unable to seen with the naked eye. Okay, after talking about the radioactive, a French scientist, Henri Becquerel, work in the lab. Okay, what he was doing, he was just working on in the lab over there. After that, what he searched? He was working on a pitch blend called uranium oxide, U2O3. U2O3 is a, just we can say, chemistry name, but pitch blend, he gave the name that pitch blend. Okay, so he was doing experiment. Like sometimes we get tired, so we close over all the things and just want some fun. So what he did, he was sitting in the lab and he was doing the experiment on the pitch blend. But what happens over there, he was not keeping success on this one experiment. So what he did, that he take a one paper, like previously we have done a photographic plate. Okay, like he had taken a photographic plate over there, and what he did, he just put a pitch blend, means uranium oxide, over there. Okay, and he just cover it up and put in a drawers. After that, when next day he came again, what he have seen, that on that one pitch blend the bright spots are coming. So he was just shocked about that, that how the bright spots are coming over there. So what happens, that the after that what he see, that on next day, one day it the got bright spotted, like on the x-ray uh, plate we were having now, like same that. So bright spots come over there, so the unseen rays came out from that, means from there the experiment happens and the unseen ray came from there. Okay, Then he gave at that time, he gave the name of that one ray, the Becquerel ray. Okay, but after that, when he has searched more about it, so he have given that a name. That name is radioactive ray. Okay, now after that, one point is remaining, that is experimental. Let me show experimental evidence. That what are the experimental evidence of his? So first experiment he did experiment from the different point, but no effect change. So it means it has highly ionized or high energy. Like how? Let me show you. Here we are having ray. Okay, this is we are having ray. This is we are having result recorder. This is the position of cooling, heating, compression, and hammering. What he did, he just passed his that ray from this all, but what he see, that this no effect came over there, and on the result recorder the same radioactive ray come again. So it means it no result, no effect is there, so it means it a highly ionized or high energy ray. Okay, move to its next point. Secondly, what he did, he strike a radioactive ray with a zinc sulfate. We have also done with a zinc sulfate plate. This is a zinc sulfate plate. Okay, it's a very shiny. What he did, that when radioactive ray strike over here, the zinc sulfate electron just got excited and move up and got unstable. But what happens, that after that, when de-excited means when again come down, okay, so it produce a one radiation, and that radiation, because of absorption and emission in the form of photons in the packets of energy, so causes produce glow. So here it produce a bright glow, and that glow is a called fluorescence. That glow is called fluorescence. After that, move to the last point. What he did, again, he strike a ray with a photographic plate. In the photographic plate, he painted again the photographic plate with uh, silver bromide. Okay, silver bromide. When a ray strike on a photographic plate, means the sign of photographic plate was 2Ag plus 1, means the loss of electron, oxidation reaction is happening over here, and Br minus 1. When it just strike over there, it break down the chemical compound of what, of silver bromide, and after that oxidation reaction change its position, that 2Ag plus Br 2. Now these both got 0 and 0. Why this both got 0 0? Previously it lost its one electron, okay, and it gained one electron. Now what it did, that it's when the reaction break down, so it lost its electron, means bromide lost its electron, so it got a zero charge, 0. Okay, when it gain one electron, so it got a zero charge. So after breakdown, this reaction happens with the radiations. Hope you understand today's lecture. Thank you so much for listening.